Today we're doing the distributive property. Hey, look, some vocab to get it out of the way. And feel free to pause and write these down to fill in the blanks. But a term could be a number, a variable, or the product of a number and one or more variables. A constant doesn't have a variable. It's something like 11 or 56. No letters. Coefficient is a numerical factor of a term, and then like terms have exactly the same variable factors. So that could be something like 11 and 46. You could add or subtract those because they don't have any variables. You could do like 4x squared and 9x squared. They're both x squared. Those are like terms. Now, if you had something like, and don't write this, 5x to the third and 2x to the second, those have different exponents with the variable combination. So these are not like terms. You wouldn't be able to combine those. Keep that in mind. So we're going to learn the distributive property, which you probably have seen, but it's a bit of a refresh. And you see this a lot in Algebra 1. It's when you have some stuff in the parentheses and there's a number and a variable on the outside. You have to multiply it to each term inside those parentheses. So if you look at example 1 here, we have the 2 on the outside, and inside that parentheses is the x plus 7. So we have to multiply the 2 into each of those. So 2 times x is just 2x. And then 2 times positive 7 is positive 14. So we have 2x plus 14. Check if you have any like terms that you can combine. And no, they would have to both be x's or both not have any x's, right? So these are unlike terms. We just leave it then. Most of the time when you distribute, the number's going to be out in front. However, on example 2, that 3 is at the back. It means the same thing. We're going to multiply the 3 times each of these terms. 3 times 2x is 6x, and 3 times negative 9 is negative 27. That's it. Usually, putting it into standard form means you always put your x's first, or like your highest exponents first. And these problems both worked out that way. In the future, it won't always work out that way. So you might need to readjust. And then this try problem, I'd like you to try, but let's keep in mind there's an invisible number here after that negative. It's like negative 1. So you're multiplying in the negative 1 to each of those. Pause it, try it, check back in. Negative 1 times 2x is negative 2x. Negative 1 times negative 3 is positive 3. That's it. Now when you have a negative and that's the only thing you're distributing, there's kind of an easy way to think about it. Just make everything its opposite. Right? When you multiply by negative 1, you just make it the opposite. So example 3, we got a bit of work to do here. So the only thing on the outside of that parentheses is the 2x. So this can be a little tricky because we have to do 2x times x, which is like 2x times 1x. That's a property we hit pretty hard later on in the year. I'm just going to bring down this negative 5x for a second. Now when you're doing 2x times 1x, just multiply the numbers in front. 2 times 1 is 2. And when you do x times x, when you are multiplying and you have the same base, you're going to add the exponents. And you're like, there isn't an exponent. There's an invisible 1 there. So x times x would be x to the second. So 2x times x would be 2x to the second. And then 2x times negative 3, 2 times negative 3 is negative 6. So this would give us negative 6x. Then you want to look for, are there any like terms? Anything that have the exact same endings on them? And if you look, these are both just x to the first, right? Negative 5x, negative 6x. So we will be able to combine those. The 2x squared, that's the only x squared. So we're just going to leave it. And then negative 5 plus negative 6, or negative 5 minus 6, is negative 11x. You only change exponents when you multiply or divide. When you add or subtract, you keep it the same. So that would be our final answer there. Let's try out another one. Now this one, there's an invisible -1 out in front, or you can just remember, make everything in the parentheses its opposite, so that would make it -10a and +11. I'm going to bring down the other stuff, the 5 and the +4a. Usually you write your variable expressions before just your normal numbers. So I'm going to combine the -10a plus 4a, and I'm going to write that first. -10 plus 4 is -6a. And then our regular integers, we just have 5 plus 11, that's 16. You can't combine those terms. They're unlike terms, so you're all done. So I have one here for you to try. Go ahead and pause it, give it a whirl, see how you do. So let's see, -5x minus 3x minus 4x squared plus 5. So my highest exponent is this -4x squared. I would write that first. We don't need to worry so much about order right now. We'll figure that out later, but we can form good habits now, and then it's easier later. Regular x's to the first power, we have -5 and -3. That would be -8x. And then we have this plus 5 back here. And these are all unlike terms. We can't combine any of these anymore. So we're all done there. All right, I think these are the last ones. 5 times the quantity x plus 6. So when you see words like quantity, that's going to indicate parentheses. So the quantity x plus 6 would be like x plus 6 in parentheses. And then you have 5 times that. That just means the 5's going on the outside. That's all it's asking us to do, but we might as well practice distributing that as well. 5 times x is 5x. 5 times 6 is 30. That's it. There's one here for you to try. Give it a whirl. Check back in. Twice would mean 2 times the quantity y minus 8. 2 times y is 2y. 2 times -8 is -16. That's it, man. Look at us distributing.